Hi guys, and happy Monday. Welcome to week 4. We're going to be talking about ellipses and hyperbolas, starting off with ellipses. So an ellipse is a set of points in a plane that is the sum of the distances from two fixed points called foci. Some people say foci, but I kind of like foci better. It's kind of up to you. So an ellipse is going to be that oval kind of shape that we talk about, where in the middle we have the center, and then on the two endpoints, I guess you would say, those are our vertices, and then further in are going to be our foci. One would be a focus, two is going to be foci, and then on the other side, those two dots that I just drew are called co-vertices. You'll see that on the next slide that we go through. We can have an ellipses or an ellipse. It's either going to be horizontal, meaning that it's kind of flattened out, it's longer in the horizontal way, and you're going to have the center, the vertices, and the foci all on the same line. So you have, from the center to the vertex, which is in blue here, you have the center to the foci, which is in orange, and then you have another value, which is going to be the center to the co-vertice, which is going to be up in purple. You can have this not only horizontally, but also vertically, and all of these different lines, the blue, the orange, and the purple, they're assigned a specific value. So as you'll notice here, as you have these two lines attached to the two foci, as you go around the ellipse, the red plus the blue, no matter what, will always stay constant. It'll be the same length. Now, depending on whether or not our ellipse is horizontal or vertical, we would call that our major axis. So if it's horizontal, you could kind of say the major axis is going to be the x-axis going left, right, and then the vertical would be your y-axis going up and down. So either your x or your y-axis. Now, there's two different standard forms, just like there was for parabolas. They look extremely similar, except the denominators are going to kind of flip around depending on whether your major axis is horizontal or whether your major axis is vertical. And what you'll see is that a squared and b squared will flip around. So the setup of our ellipse looks like kind of what I was saying earlier, where you have your center in the center, and then you have your foci and your vertices all along the same plane or along the same line, being left to right horizontal or up and down vertical, and then the co-vertices or the co-vertex of each side is going to be on the opposite. So if your major axis is the x-axis, your co-vertex is going to be along the y, going up and down. So center is going to be the same h, k. For my vertices, you're going to add the so-called a value, add or subtract, to your x value only, to your h value of your center, because you're going to be going left and right, if it's that one, and then you're going to add or subtract this a value to the k of your center if you have a vertical ellipse. For your co-vertice, you're going to add a specific b value to your k if it's horizontal, and then you're going to add or subtract that to your h value if it's vertical, and then you have your foci, which is going to be represented by the c value that we're going to talk about when we do some examples. So I recommend in your notes you draw down these two ellipses where I have the a, b, and the c labeled. This is going to help you when you do some problems in the future. So a is from your center to your vertex, b is from your center to the co-vertex, and c is from the center to the focus or the foci in either direction, plus or minus. So I suggest you draw that out before we move on. And then we have at the bottom equation for finding c. So c squared equals a squared minus b squared, or the square root of a squared minus b squared, to find that c value, which is the distance from the center to the focus. All right, so we're going to go ahead and look at the very first example, which asks us to find an equation for the ellipse shown below. The first thing you're going to want to notice is that our ellipse is vertical. Our major axis, I guess if we want to use vocab, is up and down, so it's going to be vertical. That means I want to use the equation x minus h squared over b squared, and then y minus k squared over a squared equals 1. And a little trick here to identifying whether it's a horizontal or a vertical ellipse is to look at your a squared value or the largest value. The largest value of the two, it's going to be vertical if it's under the y minus k squared. It's going to be horizontal if it's under the x minus h squared. So what I'm going to do first is I'm going to go ahead and take a look at my ellipse and just determine the center. That's going to be pretty much the easiest thing that I can do. So if I look kind of in the middle of all four of these points that I have and calculate that, it's going to be approximately, let's see, -1, -2, and then 3 comma negative 2. So in between those two is going to take me to positive 1 comma negative 2. Now that I have the center, I can go ahead and start calculating my A and my B value. So since I know this is a vertical ellipse, from the center to the vertex at the top or to the bottom is going to be the distance for A, so it's going to be 4, because I'm going from negative 2 to positive 2, so that's going to be a distance of 4. That horizontal distance to the co-vertex is going to be my B value, like I labeled above. So from 1 to 3, that's going to be a distance of 2. Now since I know my center and my A and my B value, I'm going to go ahead and plug these numbers in. So into my equation, I'm going to get x minus 1 squared, and always plus in the middle, and then y plus 2 squared, because minus negative 2 gets me plus, so I'm going to take care of the numerator. And then on the bottom, b squared, 2 squared is going to get me 4, and then 4 squared is going to get me 16 equals 1. So that's pretty much all there is for the equation of my ellipse. I just want to plug in the center and my A and my B value, and it's also asking me to find the foci. Equation to find the C value. C is always going to represent that focus or the foci, and that's going to be C squared equals A squared minus B squared. In my equation, I already have A squared, which is 16, and B squared, which is 4, and then I end up with C squared equals 12, and then I have to square root both sides to get C equals the square root of 12. Now, I always want to check if I can simplify this, so it's actually going to be the square root of 4 times the square root of 3, which simplifies to 2 square root 3. So my C value, the center to the foci, is about 2 square root 3, and since my ellipse is vertical, I want to go ahead and add that to my K value of my center and then subtract it to the K value of the center, and you can see me double checking here up in the notes. So my H value is going to stay the same. It's going to stay 1 comma, and then I'm going to take negative 2 plus 2 square root 3 for the first foci, and then I'm going to take 1 comma negative 2 minus 2 square root 3 for the other foci, because I have two of them, 1 plus and 1 minus going up and then going down from the center. Alright, and here you're going to see an equation in conic form, so it's not factored out for us, we have to make it so, and I'm going to notice that in between the y squared and the x squared term it's a plus, so I know that it's going to be an ellipse because it's always going to have a plus in the middle. Now first thing we want to do is always separate your x's and your y's, so I get the 16x squared plus 64x plus the 9y squared minus 18y equals 71, because I'm going to add that 71 to the right hand side. Now I want to go ahead and complete the square for both of those, just like we did in the circles. So whenever your A value or your coefficient on the x squared isn't 1, you want to go ahead and divide that out. So I'm going to divide out 16 and get 16 times x squared plus 4x plus blank. I do the same thing with 9 to be left with y squared minus 2y plus blank equals the 71 on the other side. So now when I complete the square, 4 divided by 2 squared is 4, so I'm going to add that in there. And then negative 2 divided by 2 squared is going to get me just plus 1 equals 71 plus 64 plus 9. Now the way I get 64 is I do 16 times 4 when I'm completing the square, and then 9 times 1 to add the 9. So that becomes 16 times x plus 2 squared plus 9 times y minus 1 squared equals 144. And to finalize my answer, my ellipse has to equal 1, so I'm going to go ahead and divide both sides by 144. And then when I simplify the coefficients, 16 divided by 144, it leaves me 9 in the denominator. So I get x plus 2 squared equals, or over 9, plus 9 divided by 144 is going to leave me with 16 on the bottom, and then equals 1 on the right side, because 144 divided by 144 gets me 1. So now I have to sketch that on my graph, so I'm going to bring that equation back up, clearing the work that we had just done, and make sure you have a plus there in the middle. And there's a few key things that I can pick out from this. I can pick out the fact that my center is going to be negative 2 comma 1, and then also I have my A and my B value. The reason why I know that A value is 16 is because, again, your A value is always going to be larger than your B value. So I know since B is first and A is second, this is going to be a vertical ellipse. Again, my h comma k, my center, is negative 2 comma 1 from the equation. A is going to be the square root of 16, which is 4. B is going to be the square root of 9, which is 3. So what I've started doing is drawing. So negative 2 comma 1 is a dot kind of line there in purple. And then my A value, since it's vertical, is going to go up 4, down 4. My B value is going to go right 3 and then left 3 from the center. That's going to be my ellipse. Very poorly drawn, but hopefully you get the point. Now I'm finding my focus, or my foci, which is going to be my a squared minus b squared, which I get 7. Square rooted is square root of 7. And again, to reiterate, since this is a vertical ellipse, I want to take my foci, or my focus value, my C value essentially, and add it to the K of my center. So I'm going to add that to 1 and then subtract it to 1 to get my 2 foci points. Alright, now here we are with some example problems, starting with the first one. Don't forget, you always want to group your x's together and group your y's together and get your constant to the right hand side. So I'm going to have 9x squared minus 72x plus y squared plus 8y equals negative 16, because I want to go ahead and subtract 16 to the right hand side. After I do this, I got to follow the completing the square process like we did before. My coefficient needs to be 1, so I'm going to divide by 9. I get x squared minus 8x plus blank, and then there's no coefficient, well, it's a 1 in front of the y squared, so I'm going to leave that as y squared plus 8y, and then equals negative 16. Negative 8 divided by 2 squared is 16, and then 8 divided by 2 squared is 16. Now I have to remember I've got to do 9 that I originally factored out times 16 to get plus 144 on the right hand side. And then for the y value, for completing the square, I'm just going to add 16 because there was no coefficient that I had to factor out. So what we get is 9 times x minus 4 squared, because of that subtraction sign, plus y plus 4 squared, which equals negative 16 plus 144 plus 16, which is 144. Now my right hand side has to equal 1, so I'm going to divide everything by 144. From the last problem and example, we know that 9 divided by 144 should leave me with 16 in the denominator, so x minus 4 squared all over 16 plus y plus 4 squared just over 144, since there was no coefficient to pull out, equals 1. And that's going to be my final answer for that equation. Alright, example number 2, same kind of thing. Group your x's and your y's together. I'm going to try not to say everything on this one because you can see what I'm doing when I'm writing it down, but I'm grouping everything together here and subtracting 9 to the right hand side, so I get equals negative 9. Now, completing the square, I got to factor out that 9 that's in front to make a coefficient of 1. So we get 9 times x squared minus 2x plus blank, and then I'm going to go ahead and factor out that 16 to be left with y squared minus 18y, and my apologies, that should say 18y, and then equals negative 9. I'm going to complete the square. B divided by 2 squared, we get 1, so 9 times 1 is plus 9 on the right hand side, and then negative 18 divided by 2 squared is 81, and then 16 times 81 to get that number that I add to the right hand side is going to be 1,296. So continuing to factor, I get 9 times x minus 1 squared plus 16 times y minus 9 squared equals, adding all those together is just going to be 1296. Now I got to divide everything by 1296 to get it equal to 1 on the right hand side. Doing some calculator work, 9 divided by 1296 is going to leave me a denominator of 144, and then plus y minus 9 squared on the numerator, and in the denominator 12 divided by 1296 is going to leave me a denominator of 81 equals just 1. And just to test that little trick I was saying earlier, my larger number is 144, so that's the a value. Since it's under x minus 1 squared, this is going to be opening horizontally, or it's going to be a horizontal ellipse, if you will, because the larger number is under the x minus h squared. Alright, example number 3. So I'm going to speed through this one a little bit more. I'm going to group my x's together, but I'm going to factor out that 4 coefficient at the same time. So I get 4 times x squared minus 6x, because negative 24x divided by 4 is negative 6x, plus blank equals, plus 9 times, if I divide out 9, it's going to be y squared plus 4y plus blank equals adding 72 to the right hand side because it was originally minus. Now completing the square, I get a 9, and then 4 times 9 is 36 on the right hand side. Completing the square, I get 4. 9 times 4 is adding another 36. So I get 4 times x minus 3 squared plus 9 times y plus 2 squared equals 144. Just like we did before, I have to get that equal to 1, so I'm going to divide everything by 144. Dividing 4 divided by 144 is going to leave me with 36 in the denominator, and then as we know from before, 9 divided by 144 is going to leave me with 16 in the denominator equals 1, and that's going to be my final answer. Again, this will open or be a horizontal ellipse because the 36 is larger than 16 and it's under my x minus h squared term. And last but not least, number 4. So there's no coefficient here to divide out, so I'm just going to have x squared plus 14x plus blank, and then I can divide out 4 for the y, so I'm left with y squared plus 18y plus blank equals negative 273 because I have to subtract it to the right hand side. Now to complete the square, 14 divided by 2 squared is 49. There's nothing to multiply that by, so I just add it under the negative 273. And then 18 divided by 2 squared is 81 times the 4 that I originally had to take out is going to be 324 added to that. So I'm going to be left with x plus 7 squared and then plus the 4 times y plus 9 squared equals whatever negative 273 plus 49 plus 324 is, which is 100. And then I want to make sure I go ahead and divide everything by 100. So since there's nothing to divide on the first term, it's just 100 for the denominator, and then 4 divided by 100 is 25 in the second denominator equals 1. That'll get me the final answer. And again, this horizontal ellipse because 100 is a larger number of the two, so that is the A value. Here we are into the next section, hyperbolas. So hyperbolas, kind of very similar to our parabolas, but there's two of them. So it's like if you take the two cones and you slice them, you're going to have that top part, which I kind of very poorly drew, and then that bottom part. And again, very similar to our ellipse formulas, except for you'll notice that there's minus signs in the middle, not plus signs, and that's very important. And my A and B don't flip. My denominators don't flip around for these, but my numerators do. So instead of x minus h squared and y minus k squared always being in the same spot, for a horizontal hyperbola, it's going to be the x minus h squared first, and then for a vertical hyperbola, the y minus k squared is going to be first. So you'll notice here that we have the center still going to be the same. It's the same kind of concept. The distance from the center to the vertex is going to be a. The distance from the center to the focus is going to be the C value, and then the B value is going to create out like a 90-degree angle with the focus and the vertex, which I'll show you in an example. I didn't draw it out here, but it kind of creates a box, making our asymptotes like an asymptotal box, if you will, but I'll explain that later. And then we have our two asymptotes here in the formulas. So they're exactly the same, except for the main difference is that if you have a horizontal hyperbola, you want to do your B value divided by your A value for that coefficient in front of the x minus h. And then if you have a vertical hyperbola, you want to do A divided by B for that coefficient value, and it's going to be plus or minus because you're going to have two asymptotes. You're going to have one at the positive slope, and then you're going to have one with the negative slope. And here's a picture where you can kind of see what I was talking about, that asymptotal box, if you will. So you have A going from the center to the vertex, C going from the center to the focus, and then B going out a certain distance, which creates this box for which of the corners the asymptote is going to run through. So a little bit complicated when you talk about it, but when we see it in action in a problem, it's going to make a little bit more sense. Alright, so for our first example, the first thing I'm going to want to notice is that we have a horizontal hyperbola, so we want to use the equation where x minus h squared is first, divided by a squared, and then minus, so this is going to be minus for our hyperbolas, y minus k squared over b squared equals 1. So I got to find the center and my a and my b value. So the center, h comma k, is going to be the midpoint or exactly in the middle between my two vertices, and also your two foci as well. So if I find those 2 points, which it looks like is 0, 2 and 2, 2, my center is going to be at 1, 2. And then my a value is going to be the distance from my center to my vertex. From 1, 2 to 2, 2 is just a distance of 1, or vice versa, the other way to 0, 2 is just going to be 1. And then my b value, I don't quite know yet because I don't have that asymptotal box, if you will, but I can figure out the c value because that's the distance from the center to a focus. So from the center 1, 2 to let's say 4, 2 is going to be a distance of 3 going to the right. So I know that a squared plus b squared equals c squared, so 1 squared plus b squared, which I'm trying to find, equals 3 squared. So 1 plus b squared equals 9, subtract by 1 we get 8, and so b equals the square root of 8. or just b squared equals 8. Now that I know my center, I know a, I know b, I could just go ahead and plug in these values. So I get x minus 1 squared over 1 minus y minus 2 squared over 8 equals 1. And if you want, you can simplify that by getting rid of the denominator of 1 and just leaving the denominator of 8 over under the y minus 2 squared. So for problems like these, I recommend you find the center first, which is going to be 0, 0. There's no h or k value here. So I also know it's going to be a vertical hyperbola because the y value comes first and we see y squared. Now to find my a value and b value, that's pretty simple. A is going to be the square root of 25, and then the square root of 36 is going to be the b value. Very quickly, I'm going to find that c value by doing a squared plus b squared square root it. 25 plus 36 is 61, square rooted is going to be the square root of 61. And so I'm going to start by graphing the center of my parabola, or of my hyperbola, which is going to be at 0, 0. I know it's going to be vertical, so that a value of 5 is going to take me 5 units up. So that's going to take me from 0, 0 to 0, 5, and then down as well to 0, negative 5. And then the b value is going to be how much I want to go out to the right and out to the left from my center. So from the center up and down, I'm going to go 5, and then from the center left and right, I'm going to go 6. What I also did is I found the square root of 61, which is approximately 7.8, and the c value is going to be the distance from the center to the foci. So a lot of pretty important pieces of information here. I'm going to graph all these different pieces, my center, my vertices, my foci, and it's going to approximately look like that, and I'm going to try to find the asymptotes to see where those diagonal lines are going to be. So I'm going to take y minus k, but k is 0, but y minus k equals, since it's vertical, I'm going to do a divided by b times x minus h. Well, h and k are both 0, so that's going to turn into y equals 5 over 6x, and then also the negative, because I'm going to do plus and minus, I want both. This is a linear equation with just a slope of 5 over 6. So I can go up 5 over 6, make a dot, down 5 over 6, make a dot, right 5, down 6, make a dot, and then left 5, up 6, make a dot. And this is going to make my asymptotal box, if you will, that I was talking about earlier. Or I'd find that with my A and my B. So my A goes up and down 5, my B goes left and right 6. That's going to create my box going all the way around 5 and then 6. Now through the corners of that box is where my asymptotes are going to go through. Just as you see here, my dotted lines, so there are my asymptotes, and I know that my hyperbola can't pass those two lines at all. And so I erased the old graph that I have, and here in obnoxiously large green, I went ahead and drew kind of the new hyperbola, going through approximately 5 and negative 5 and going closer to my asymptotes than they were before. Now for our next example, I'm always going to want to try to keep a positive term in front. So instead of keeping the negative x squared in front, I'm going to switch the y to be in front. So 4y squared minus 24y, and then the minus x squared minus 2x equals negative 19 because I want to subtract it over. Now I'm going to factor out that 4 like we've been doing, completing the square, I get plus 9. And now here's something new that I'm going to do is instead of leaving that minus, I'm going to factor it out so that negative 2x squared turns positive as well. So it's going to be a positive 2x. And then 4 times 9 gets me the 36, and then that negative that I factored out times the 1 from completing the square gets me the minus 1. So I end up with 4 times y minus 3 squared minus x plus 1 squared equals the combination of all of that, which should be 16. And then just like we did with the ellipses, I'm going to go ahead and divide all of this by 16. 4 divided by 16 leaves me a denominator of 4 for the first term, and then nothing, or negative 1 technically, divided by 16 leaves me with a 16 in the denominator for the second term. Now I have to go ahead and sketch that. The y term is first, so that's going to be a vertical hyperbola. I know my center is going to be negative 1, 3 from the equation, and then I know my a value, or a squared, is going to be 4, so that means a is 2, and then b squared is 16, which means b is going to be 4. Now, to get my vertices, I take that a value and I add it to my k, so that's why you see 3 plus 2. I'm actually going to do 3 plus and minus 2 to get those 2 points. And then I need to find the c value. So c squared equals a squared plus b squared. As you've heard me say before, c squared equals 20. And then square root both sides, so c equals the square root of 20. Or if you want to go ahead and simplify that, that's going to be 2 square root 5. Or if you want to go further and give yourself a decimal approximation, we're going to have approximately 4.5. So you'll see I graph my center at -1, 3. I have my vertices at -1, 5 and then -1, 1. My foci are going to go slightly above that, so it's going to be 4.5 above my center and then 4.5 below my center, so you'll see those two dots. And then my b value should shoot out from the center to the right to the left. So it's going to be to the right 4 and then to the left 4. Like I was saying earlier, your A and your B value are going to create that asymptotal box. So from the vertices to that B value out to the right and to the left, I'm going to create that kind of box. And my asymptotes are going to go through the corners, the diagonal corners of that box. And then I can draw my hyperbola going through the vertex. So make sure you kind of hit that vertex, even though I obviously clearly missed it. And then you go along your asymptotes that you have drawn. Alright, so our first set of examples are writing the equation from this general form, so convert to standard form. So I'm going to group my x's together and my y's together. I'm going to go ahead and divide out that coefficient like I've been doing, so divide out the 4, complete the square with -12 divided by 2 squared, which would be 36. And then what I also did here, what I did before, is I divided out the negative, the minus, in front of the y squared, which turned the -2y into a positive as well. And then I have equals -43. So when I'm completing the square, I took that minus that I pulled out, the negative, and then the +1 that I got. So that's going to be where the -1 comes from. And then 4 times 36 gets me 144. So I get 4 times x minus 6 squared minus y plus 1 squared, which is going to equal 100. Divide by 100 to get equals 1 on the right hand side. As I divide by 100, 4 divided by 100 leaves me with 25 on the first denominator, and then with 100 on the second denominator. And for example number 2, I'm always going to want to try to have my positive coefficient first, so I'm going to flip the y's to the front. So I'm going to divide out that 25, be left with y squared, and then the 200 divided by 25 is going to be -8y plus blank, but b divided by 2 squared, so -8 divided by 2 squared is 16. And then now I'm going to factor out that x, or that negative in front of the x squared, so that turns my positive 6x into a -6x, and then my 366, I'm going to divide that, subtract it to the right hand side. So now I get 25 times y minus 4 squared minus x minus 3 squared equals, and then I'm going to take -336, and then 25 times 16 is going to get added under that, which is 400, and then the negative that I originally factored out with the 9 is where the -9 comes from. And then I'm going to bring that down and then combine -366 minus 9 plus 400, which is positive 25. Divide everything by 25. 25 divided by 25 leaves me with no denominator on the first term, a 25 in the second term, and then equals 1. And it looks like I accidentally skipped the third one, so I'm sorry about that, but moving on to the fourth one. Again, I'm going to try to have a positive term first always, so I'm going to move my y's front. So y squared plus 6y, if I complete the square, that's going to be plus 9. And then I'm going to factor out that minus sign like I've been doing to leave x squared minus 12x plus 36 after I complete the square, and then that minus 108 becomes plus 108. The plus 9 goes on the right side too, and then -36 because of the negative that I pulled out. After I factor, that's what I'm left with, and then 108 plus 9 minus 36 leaves me with 81. And then I want to divide everything by 81. There's no coefficients in the front, so both of my denominators for this one are going to end up being 81, and then equals 1. And for our last set of examples, so I always suggest you go ahead and draw these out. So my vertices at 0, 10, 0, -10, this is going to be a very loose drawing, but we're just sketching it. It's not going to be exact. And then I'm going to take 2 times square root 41 and get approximately 12.8. So I know that they're approximately going to be slightly, 2.8 above my vertice and then below the other one. So as I go ahead and graph that, I'm going to see that this is going to be a vertical hyperbola, so I want to make sure I copy the equation the right way. I want to use y minus k squared divided by a squared minus x minus h squared divided by b squared equals 1. What I also know is that my center is directly in between my two vertices, which happens to be here at 0, 0. So if I go ahead and take my center, which is 0, 0, and plug it into the formula, my numerators really have no numbers in them. It's just going to be y squared minus x squared because there's no h and k value. All I really have to do from here is figure out my a and my b. So by definition, the a value is the distance from the center to the vertex, which I know is going to be 10. And then the c value is the distance from the center to one of the foci, or the focus, which is going to be 2 square root 41. I also know that a squared plus b squared equals c squared. So I don't know what b is, so I'm going to leave that as b in the formula. 10 squared is 100 plus b squared equals. Remember, when you're squaring something that looks like this, you want to do 2 squared and the square root of 41 squared. So 4 times 41 is 164. Minus 100 from both sides, and then square root. B equals the square root of 64, or just b squared is 64. That's all we really need. So I'm going to go ahead and plug those into my formula. Again, h and k are 0, so that's just going to be y squared over 100, because a squared is 100, 10 times 10. And then minus x squared over 64 equals 1, and that's it. For example number 2, here we go. I'm going to draw it out. So my vertices are at 3, 0 and negative 3, 0 here. My foci are approximately, so square root 34 in the calculator is going to be approximately 5.8. And based on their placement, I know this is going to be a horizontal hyperbola, or a hyperbola that opens horizontally. Since it opens horizontally, I want to make sure I use the right equation. So I want to use the one where x minus h squared is first, and then y minus k squared follows. Remember, in a hyperbola, a squared and b squared will always be in the same spot. Now, just like before, my center is directly in between my two vertices and my two foci. That's going to be at 0, 0. My a value is from the center to the vertex, which is going to be a distance of 3, and the c value is from the center to the focus, which is going to be a distance of square root 34. And if I'm going too fast, just let me know, send me a message, or whatever you need to do so I can go through it with you again. But once you do it a couple times, it gets pretty repetitive and you end up seeing pretty much what you're supposed to do. So again, like I was saying, the x minus h squared should go first. And then all I really need to do is find that b value, because I have a and I have c. And I also know my center is 0, 0, so I'm just going to preset that up as x squared minus y squared with my denominators open. So 3 squared is 9, so that's why I put 9 there. And then I'm going to go ahead and set up my a squared plus b squared equals c squared. So subtract 9 from both sides, I get b squared equals 25, and then the square root of 25 is just 5, but I really need just b squared, which is 25. And that's actually it. All right, so for example number 3, draw it out. You know the drill. I have 0, 8, 0, negative 8. I also know that my center is at 0, 0. And since my vertices are up and down, that's going to be vertical. So I'm going to make sure I use the y minus k squared is first, and the x minus h squared is second. But my center is 0, 0 anyway, so I'm just going to set this up as y squared and then x squared. Now my foci, which is square root 85 and then negative square root 85, approximately in the calculator should give me about 13.6. And then I know my a value is going to be 8. My c value is going to be 13.6, or I'm actually going to use the exact value of square root 185, and I'm going to go ahead and set this up into my equation. So a squared plus b squared equals c squared. That's going to be 64 plus b squared equals just 185, because the square root and the square will cancel. Subtract, I get b squared equals 121. And b is 11, but all I need is the b squared, which is 121. So I get y squared over 64 minus x squared over 121 equals 1, and that's my final answer. All right, guys, and this is our last example, so I'm just kind of going to let this one ride. I'm not going to talk through it because ideally we already know what we're doing right now, except for just to tell you that approximately square root of 55 is approximately 7.4, and then square root 110 is approximately 10.5. Alright guys, and last but not least, I wanted to talk you through this final part that talks about some of the characteristics of our different conic sections that we've talked about. So we have our general form right here that we're used to seeing. And there's some things that we can notice before we actually start completing the square. So you know it's going to be a parabola if only x or y are squared, not both. You know it's going to be a hyperbola if you have a minus in between, so you have x squared minus the y squared or y squared minus x squared, so a minus in the middle. You know it's going to be a circle if you have your coefficients, your a and your c, as being equal. And also you have a r squared, so you're going to have a radius. And then you know it's going to be an ellipse if you have a plus sign in the middle. So between the x squared and the y squared, you will see a plus sign. Alright, so splitting this up into fours because we've done 4 conic sections. First we talked about the circle, so that's going to be x minus h squared plus y minus k squared equals r squared. So obviously our circle is going to have a radius, that's going to be the main way to notice. Then we did y minus k squared equals 4p times x minus h and vice versa, which is going to be x minus h squared equals 4p times y minus k. You'll notice here that either the x or the y are squared. That's going to be our parabola. It's not going to be both. Then we talked about our ellipses, which has a plus sign separating your two fractions, and most importantly, your numerators do not change spots, it's the denominators. So the a squared and the b squared will flip around, whereas to the x minus h squared and the y minus k squared, those stay in the same spot. So those are going to give us our oval-shaped ellipses. And then very similarly, last but not least, we had our hyperbolas that we just talked about, where we have a subtraction sign in the middle of our two fractions, and it's not the denominators that flip around, but it's actually the numerators that are going to flip around. The a squared and the b squared stay in the same spot. Alright guys, so I know this video was a long one, but let me know if you have any questions, and good luck as you're working through week 5, and always make sure you remember to know that I'm here for you if you need any help.